The previous video segments examined mitigation of greenhouse gas emissions from the transportation and electric power sectors. The agricultural, forestry, industrial, commercial, and residential sectors summed together produce the majority of greenhouse gases, however. This segment introduces mitigation of emissions from agricultural and forestry sources. Its major points are: number one, agriculture is responsible for the majority of methane and nitrous oxide emissions. Number two, manufacture, distribution, application, and soil transformations of nitrogen fertilizer are the largest agricultural source of greenhouse gases. Number three, methane emissions from ruminants and wetland rice cultivation are difficult to mitigate. Number four, reforestation provides carbon offsets for other human activities. Agriculture and forestry are responsible for between 10 and 32% of the world's total greenhouse gas emissions from human activities, depending on how much one attributes emissions from land use changes and biomass burning to these sectors. Depending on this accounting, agriculture and forestry contribute as much as 1% and as much as 24% of carbon dioxide emissions, 47% to 52% of methane emissions, and 58% and 84% of nitrous oxide emissions. The largest source of carbon dioxide emissions is decay of above and below ground organic carbon after deforestation. Cultivation of wetland rice, burning of crop residues, and rearing of ruminants such as cows, sheep, goats, buffaloes, and camels generate most of the agricultural methane emissions. Soil and plant transformations of nitrogen fertilizer account for most of the agricultural nitrous oxide emissions. Several external factors influence greenhouse gas emissions from the agricultural sector. Agricultural lands, although they have expanded 5% per decade in developing countries and 2.5% per decade in the world as a whole, have not kept pace with population growth, and so agricultural land per person has declined. To meet rising demands for food and fiber, farmers more intensively manage the lands that are in production. Intensive management often results in a loss of soil carbon, particularly from lands recently converted from forests or wetlands to agriculture, and primarily through plowing that accelerates microbial decomposition. Such losses manifest as a net release of carbon dioxide to the atmosphere. People are now wealthier on average and can afford to consume more meat and dairy products. This dietary shift has altered the balance from producing food for direct human consumption to producing feed for domestic animals. The net result is that crop residues, which previously remained in the field and amended soil carbon or slowly decomposed to carbon dioxide, have become animal feed, and the animals release a portion of the organic carbon in the feed to the atmosphere as methane, a greenhouse gas with 23 times the warming potential of carbon dioxide. The remainder of this section glosses over these external factors and focuses on agricultural management practices that minimize greenhouse gas emissions. Nitrogen fertilization, if one includes carbon dioxide released during manufacture, distribution, and application of the fertilizer, and nitrous oxide released during microbial transformations of the fertilizer in soils, is responsible for the majority of greenhouse gas emissions from agriculture. Breeding crops for better yields has inadvertently selected for cultivars with nearly double the nitrogen use efficiency of earlier cultivars. Newer cultivars attain higher yields per nitrogen absorbed from the soil, as well as acquire more of the nitrogen applied to the soil. Consequently, grain yields in the United States have increased about 3% per year without additional nitrogen fertilization or greenhouse gas emissions. Crop breeding programs are beginning to target high nitrogen use efficiency as a primary objective. Complementing genetic improvement of crops is more sophisticated fertilizer management. Previously, farmers took a one-size-fits-all approach, whereby most fields received a similar amount of fertilizer in a single application just before planting. To compensate for possible variation among locations or over years, farmers would err on the safe side and apply an excess amount of nitrogen. Now farmers optimize fertilizer rates among fields and sometimes within fields, and they add small amounts of nitrogen to the soil several times through the growing season. Fertigation, the practice in which farmers dissolve fertilizer in the irrigation water that they apply regularly through drip irrigation systems, has become commonplace in California. This practice both conserves water and minimizes fertilizer losses from leaching or denitrification.